In this prototype, I want to improve the strategy so that I can randomly seek, I can figure out how to lock onto something. And what you can think of this as an example of what we might, or where this might come up in actual code that we write, is in the previous example, I had a simple strategy that was just randomly firing. So it doesn't really need any more information to be able to refine how it was firing. Meaning, it could just be a generator that just yields what the next action is. But if I need to refine what I'm doing, then I need to know what the result is, which means I need to pass data back into this thing. Well, as we say many times in across all of these different sessions, whenever you're doing some sort of agent model, a coroutine is actually a pretty natural choice for this. And so, let's take a look. Why don't we start by grabbing the previous code that we had and focusing our attention on the area where we want to improve it, namely this random fire. It just gives you the random positions where it's going to try and strike. But we want this to be a little bit smarter. And so we want to be able to pass more data in. And in fact, we are doing that. We're passing this result back in. We're just not doing anything with it. So here what we can say is get the next result back in, and there we go. And one nice thing about this is, as a consequence of the way in which we wrote this, the result here being none avoids this can't send an unknown value to it, just start a generator problem. However, yeah, I guess there's no really way around that. There's really no way around that. We have to send something in at the initial stage, or I guess we can have, block of code at the very beginning. But I guess, this is actually probably about the best way to do it. I think the choice for something that I want to show you, which is pumping or priming, is not going to be based off of the can't send an unknown value to a just start a generator problem. It's going to be based off of something else. Note that by doing .send, we're being very presumptuous that the strategy was implemented as a coroutine. One of the things that I like about coroutines is writing them in such a way that somebody doesn't know or have to care that it was a coroutine. It could be any sort of callable. I like this API unification between fully fledged object-oriented approaches, coroutine approaches, and just simple functions. And so what I'm going to do is I'm going to make this thing look like just a regular function. Meaning, if the strategy were fire at the same spot, and all it did was just return 0, 0 firing at the same spot, this is API compatible with whatever I have. And I guess here, just to make it, actually, it'd just be strategy equals fire at the same spot. So, something like this is API compatible, meaning that if I were to provide this to an end user, and by the way, this should take a parameter it's not going to really look at. It's basically a function of one argument. You can see it just keeps missing forever. The idea is this. Do I really want the people who are going to be implementing strategies to have to worry about specifically meeting every small little detail of some API that I have, and am I willing to put in the time to document and to train them to write it to a particular standard? Maybe, maybe not. Probably not. And so if I choose a very, very simple API, a function that takes one argument, or a callable that takes one argument that's a result of the last thing that you did, they can then choose to implement it as just a regular function, or as an object-oriented solution, or if they choose as a coroutine. And this is going to lead me to trying to pump this coroutine. I need to make this thing look like a regular function. And the way I do that is, what I'll do is I'll decorate this. One thing we know about that decorator pattern in Python is, anytime you're writing a lot of functions, you might consider that any commonality that occurs in the writing of those functions, like how you set up the documentation for those, how you wrap them in some particular before or after behavior, how you might wrap them in instrumentation, all of those things will, decorator pattern comes up here. What I'm thinking is I'm going to be writing a lot of functions, and each one of those functions will be each strategy that I'm trying to prototype. And each time I do that, I want to unify the API with how the API for just a single callable with one argument looks like. And so I'll just write a decorator here. And so it'll look something like this. Here, this will give me, this starts with what? The coroutine. And it'll turn this into a thing that looks like this, passing the args that were passed in. It'll instantiate an instance of this coroutine. And then it will do a dummy next to get past the first value, so I can just immediately start sending things into this just in case. And I'll do a send of a value, and we'll allow this to be an argument, a function of Actually, we'll make it just a function of strictly one argument. I think that's a reasonable simplification. Sometimes you might want to make it a function of 0 or 1 arguments, but here we go. So we'll do something like this. And so the only thing that we need to make this work is we may need one dummy yield if there's some initial state that we're given. I don't think we actually have that here in this game of Battleship, but it's very common to see that you're given some initial state in these agent models. So let's fix our typo and see if we were able to unify that API. Yep, that works. And now we can actually focus on the core of this. Well, we get the result. So if we take a look at this result, we can see all the results that were given. You basically are going to randomly target until the result that you got was a hit. And then you're going to just grab some of the spaces surrounding this. Now this is a little tricky because we might need to know what's surrounding this, but we can do that through a somewhat tedious approach. I think we may need to know what places we've already hit before. So we might need to have some history that we store for where we've tried to hit before. So we might do something like this. This is my target. And here we'll add this to my history, just so that we can do this. So if we manage to hit, then we can just say, there's 1, 2, 3, 4 possible other places that we could look. So we can take that target, and this is the target X and the target Y, and we can just say, we can just try to yield the target X minus 1 and the target Y. So this is our new target. Is these components. And here you can see maybe I could use a NumPy and D array for this would have made my life a little bit easier, but not too much easier. So there we go. So we just might do something like this, and we might even do this for X adjustment and the Y adjustment in the Cartesian product of. We want to go in 4 directions, so I guess we want to always do. We want it to be -1 and +1. I don't know. I think we actually need to do. If we do it like this, we're going to hit all of the squares surrounding, which assumes that you could be on a diagonal. So here we might want to actually filter this down to cases where they're not both set. Or here we could say, we can do this in a couple of different ways. I can leave it at this, and we can see that it's going to hit a lot of places that it doesn't really care about. We can refine that later. So here we go. And this might be our base X and our base Y. So here our new target is the base X plus our X adjustment and the base Y plus our Y adjustment. Of course, these variable names aren't great, but you get the idea. And we might just double check if this thing is not in the history. We actually try it, otherwise we'll skip over it, and there we go. So this thing should now basically say the moment you see a hit, you just kind of go around and you do this. I think actually we want this to be something a little bit more specific. You want to say if it's a hit and it's not a syncing, because obviously you don't want it to be searching once you see something that's syncing. Okay, with that said, I think we fixed one typo here, and this thing should have a better chance of finding things. Now, here we can always whittle this down if we want to make this a little bit better. And so the way we whittle this down is we want to say if X adjustment and not Y adjustment, or the other way around. If one of these has to be 0, in other words, we continue. So here, that should just go in a pattern. And you can see, did it actually target in? Well, let's actually find out. Let's see, targeting, and let's see what the result of that is. And of course, there's one thing here we actually need to grab that result back here. So you can see it hit the battleship. So why didn't it start targeting once it hit that battleship? It's very interesting. So let's see what's going on here. We get the shot, we pass it back into our strategy to get the result, And the moment we hit the battleship, we should know immediately after. So we should start targeting something immediately after. So let's figure out what's going on here. Okay, so we hit the battleship. We see that hit. Is that result a hit? And it's not an instance of a sinking. There we go. So here, it hit the battleship, and then it looked around. I wonder why it didn't find that immediately. So let's see where it's going to target next. And what we'll do is we'll say, we know what the base is. So here, we'll take a look at the base and then where it's going to try and hit next, and we'll see if there's a little bug there. But for the most part, okay. So what happened was it hit the battleship, and of course we started going off the board. So we gotta do a couple of checks in here. And you can see where maybe if we had a better modeling of the board, we could ask the board for all the adjacent spots, or maybe if we had some other modeling here. So I think here we have to be just a little careful. So we have to say if 0 is less than, and here we also need to know what the board size is. So if 0, the base x, plus the x adjustment is less than the board size. So if one of these isn't the case, we will skip. So and I think that should give us something that's visually much clearer of a targeting. It should lock in, and then, okay, there you go. So you can see it went for the battleship, and then it went around, and then it missed, and so it then went searching again. So why didn't it went around, and I think what we actually want is a loop where once it hits again, it goes deeper. So it tried the 4 spaces around the place where it hit. I'm guessing it probably hit, let's think. If it hit somewhere in the middle, it would have hit again. So we got to just see why. So it went from 0, 0. And let's double check. Let's actually make this a little bit easier. If this thing is not equal to 0 and this thing is equal to 0, if they're both not equal to 0, then we're going on a diagonal, so that's not allowed. So one of them has to be equal to 0. Let's see if that solves our problem. Okay, we missed, and then we hit again. Okay, then we tried again, we hit again. Very good. And so I think that probably what happened is we hit at the far end, and then it hit again at the next stop, and then it needs to kind of repeat that analysis rather than keep shooting in places that it doesn't see. So the next thing that we're going to do here, just to see if we can wrap this up, but I think this is going a lot better than what we had before, is if this consequent result was a miss, then we keep hitting. But if it's a hit, then we kind of know the direction. So if this thing was a hit and not a sinking, then we have now a sense of what the direction is, and then we can go into another portion here. What you can see here is that the ultimate strategy is really randomly fire, hit something, do a pattern search around it. Once you find something, then you know what the orientation is, and you just go linearly straight to the left, straight to the right, straight up, straight down. And what you can see is that general idea, those inner loops, are actually preserved within the coroutine formulation. We have the outer loop of the random targeting. We have some inner loop of our strategy for figuring out how to circle around that hit. And then we'd have one more portion here where we'd say, okay, now we know that we've got 2 hits in a row. Now we can figure out how to triangulate from that what the orientation of the ship is and then do something there. And I'll leave this here because I think I've proven that we're able to implement this more sophisticated version of the game.